Welcome back, everybody. Our next talk will be held by Yarheva, Saurabh Gupta, and York Zalander, and they will tell us about their 8 years of experience with EventSourcing CQRS. Have fun.
So it will be me to start. So, welcome. My name is York Zalander, and I'm the CTO of Bettermarks, and these are my dear colleagues, Yarheva, who's our software architect, and Saurabh Gupta, who's our system architect. And in order to understand our journey and to understand the journey we made, I would like to give a short introduction on what is Bettermarks. So Bettermarks is an adaptive learning platform for maths in school. We currently cover grades 4 to 12. We have roughly 500,000 users per school year, and we're available in 4 languages: German, English, Spanish, and by chance Dutch. And that's one core principle in our product, and it's called learning from mistakes. So we have adaptive workbooks, and in these the children find exercises, and they are highly interactive, and we give immediate feedback to what the children are doing. And we give formative feedback, and that's the crucial part, children always have a second attempt to apply what they have learned. And this is what gives rise to aha moments, and this is the core magic of Bettermarks. So we produce some 700,000 aha moments per week, and that's what really makes us proud. So in order to understand our endeavor, I'll have to introduce a few product components we have. One component is the so-called student center. So we're working in school. Teachers can assign homework or work in the school. So in the student center, the main view is a student sees the work she or he has to do. Then they can click on play, and the series player is started. This component is where the student interacts with our content. Of course, there's the according teacher center. Teachers have much more information at their fingertips. Teachers work in the context of classes. And this is the dashboard of the teacher center, so a teacher can see the progress that the group and the class is making. And there's one tiny tab on top of this, and it's the classes tab. And this is where the teacher can modify the structure of the group the students are working together with, him or her. But as we are working together with very different countries, federal state schools, this only applies situations where we provide our user class management, our own user class management. But we integrate it into tons of other systems. For instance, there's the Schulcloud, which is being used in the federal states of Niedersachsen, where we're embedded in the federal IT system called the Schulcloud. So the left-hand side is coming from Schulcloud, the right-hand side is coming from Bettermarks. So there's an integration, and this user class management thingy is somehow separated away. So let's have a look, a very small glimpse at our domain model. We can distinguish at least 3 subdomains. So then first of all, there's the content domain. So we have our workbooks, and these are exercise series, and in these exercise series are exercises. On the right-hand side, we have the user class subdomain. So we have classes, we have students, we have teachers. But the core, the adaptive core, is the learning and teaching subdomain. Here we have the assignments I mentioned. So teachers assign work to students. There are allocations, so they can hand out certain workbooks to students. And the results, the dashboards you've seen, are also part of this domain. And our focus today will be on this domain because this is where we applied event sourcing. And just to give you a short glimpse on how we've sliced our system design. So in the center is the adaptive learning system. We have the integration system, which separates our own user class management system from other class management systems out there. We have our own content creation system, so our content authors are creating these interactive contents. And we have our learning analytics systems, which is being used by our authors and by our product people to understand what's going on. So this is roughly the setup, and that should be enough to head over to Yar.
Around 2013 to 2014, we started a rewrite of our product, building a much more structured architecture. And this is where we introduced event sourcing. So one important learning we can have from that entire endeavor is do not use the term, the word new when you're creating any component, because very soon it becomes old, and then you have the old thing that's called new and the new thing that's not called new. And so I'll give you a brief sketch of how it works. So we already saw the teacher center and the student center. They were built with AngularJS, the first version of Angular. The series player, which was built in Flash, so in ActionScript. Yeah, that's the front-end side. The back-end side, everything was deployed in a local data center here in Berlin on dedicated servers, on virtual machines on those dedicated servers with our own custom-built scripts for deployment and so on and so forth. Those dedicated machines, just remember, it means that they need to be ordered in advance. It takes time, and if you need more, these are long-running contracts with a fixed price, and so on and so forth. Then we have the backend, which was built in a fairly monolithic way. So it does everything. It has all the API, and it handles the event sourcing in both parts. It dispatches the events, so it would get events from the front end and then dispatch them to the EventStore. And it does the aggregation, creating the projections in process inside the backend. If we scroll down, then the event store and the snapshot store and the session store and the user class store, these are all in MongoDB that was self-hosted, deployed by us, all on the same replica set. But we could already leverage our event sourcing for BI. So we have a message queue that goes to an ETL that stores that in a data warehouse, also stored in that local data center. So why event sourcing? Our events are related to activities of the students and the teachers, and activities of the classes. So they would be a series. Here stands for exercise series. So a student started the series, ended the series. Inside the exercises there are steps. The steps could be finished. And projections would be things that you would want to learn from that. So did the student finish their work? What is their score, which we call coins and stars? Dashboards that give insights to the teachers over the learning progression of the students. And the reasons are, so we thought that would be easier to scale at a lower cost. The learning events have natural business relevance. So basically, the state of the state of the student and the teacher are interrelated. So they could be seen as different views, different projection of the same data, which is seen from different perspectives. And that is the foundation of, well, we are an adaptive learning platform, so of our adaptivity. The events of learning are used as information on top of which we can gain insight on the learning progression of the student and who needs help, how, and so on. So some notes about the implementation decisions, which I guess are more like looking in retrospect what we decided. The projections are created on demand. So the events are stored when they are stored, but the projections are created only when the user requests the data. And so all the events are collected, aggregated. The result is stored as a snapshot and then given back, which means that essentially this is write on read. Right? So every time you want to read, you first write. Because the written snapshot allows us, the next time that we want to aggregate, to start only from the last snapshot. Everything is in one database. You saw that before. And all the partners are on the same database. Nothing was sharded or anything. Yeah, this is all to keep things simple. Yeah, it says no aggregates projections only. It's a bit of a philosophical question, but essentially we're using just projections. The point that is important is that inside the code, the terminology that we're using is quite confused. So we use the term aggregate, sometimes to refer to snapshots, sometimes to refer to projections. There's a bit of a mess around understanding these concepts. The projections are, or the snapshots are stored as MongoDB documents, which have a size limit. And one interesting pattern that we are using is that we are creating secondary events, specifically for knowledge gaps. This is basically to understand what kind of knowledge a student might be missing based on the mistakes that they have made in their exercises. And we are creating them at the time of creating the projection, which is on demand, as I said earlier. So these were some of the implementation decisions. As a whole, this worked very nicely. So this architecture worked very well. And one essential event that is kind of the heartbeat of our product is exercise series finished per minute, right? Which we were able to reach 200, so pretty nice. And an interesting thing to note is that we built EventSourcing CQRS without knowing DDD. So we built the events without first modeling our domain. And yeah, I'll pass now to Saurabh, who will tell us a bit about the operational aspects of that.
Thank you, Yar. So after we had built our first implementation of event sourcing and CQRS, we ran into a couple of operational problems. First one is, as Yar said, we were doing aggregation or projection calculation on demand. So what happened that whenever you change your version of projection or you want to introduce a new product feature to change shape of your projection, we need to get a new version. And since we will drop the old projection, in the morning when all students come to school, log into Bettermarks platform, all will bombard our platform to create their projections once again. And that led to a huge problem, and we were always super slow or even sometimes not available. So at least to work around to solve that problem, to release new versions of projections, at least we implemented a async replay mechanism. So every time you want to update a version of a projection or a aggregate, in that context, we had background jobs and scripts, which will ensure that every release process can update all projections in the background, so that at least in the morning when new users comes again, they can get the latest copy with the minimal impact on our platform. That was a huge learning we wanted to implement further in our product. However, what we learned that once we rolled it out and became stable, we had a very interesting feedback from our partners that they also wanted a view into event stream that their users are producing on our platform. So in that context, the EventStore CQRS come to rescue. It was super great because for our own purposes, we are writing our events to a message queue. So what we did was that we just expose message queue endpoint to our partners and share the documentation of our events of an API, and then partners were free to consume those events and then create their own analytics and reports as they like. So that was a really cool feature that we were able to leverage by using event sourcing and CQRS. However, this was not a happy story when we work with partners. So typically, I think all of us can relate to this statement that users will always do what you don't expect them to do. So in that context, our platform is meant to be an adaptive learning platform, and that means that you are supposed to use in a systematic way to plan students' learning path so that they can learn maths effectively. However, to promote learning of mathematics and to be able to have a solid path, some of our partners started to perform math competitions. In the math competitions, if they do in a systematic way, it's a great use case. However, just to win the competition, because there were some financial incentives linked to the how a class or group is performing, they end up creating really, really large series. That means a given series for students will have 100 or 1,000 exercises. And even for those, they will end up creating thousands of exercises containing thousands of series. So that really lead to a lot of unexpected abnormal usage, as we were using MongoDB database and we were using snapshots. So sometimes the projection or the aggregate you want to store in DB was exceeding the size. So many times the users were not able to get the up-to-date view of their current activity. And then MongoDB exploded because of that. And also to win the competition, we also observed that a lot of students were able to figure out writing simple scripts, and they were cheating the system by just bombarding to send an event which is completed. So basically, that was a huge learning lesson that first, always ensure that you have a well-defined limits on your product, so it prevents your product from incorrect usage, and at least users are warned promptly that you are using platform in a way which is not supposed to be. And second was that since we put all partners into a same infrastructure segment, it was not a wise decision, because the activity of one partner led to the fact that our platform was down for everybody for 6 weeks. So that's why it's always advisable to please segmentize accordingly so that you can minimize the blast radius when those things happen. Another aspect of our event sourcing that helped was change of school year. So what does it mean in school context? As all of us have gone to school, so every time you go to a school, you change a class, then you learn new topics, and then teacher who taught you the last class want to start from afresh. So this is why it was very important feature requested by teachers. At the same time, they requested that they don't want to lose all the data. They wanted to keep at least what kind of knowledge gap was not completed by the student in a previous year. Or they wanted to have an overview of how a given student like Yar or Saurabh did in the last year. This is where our new process evolved, where we dropped almost 90% of our events and only kept the events which are relevant for a teacher to know what kind of knowledge gaps were detected for a given student last year, and have a summary of the report. So yes, we do we do empty our event store every year as a part of our change of school year operations, and we drop roughly 500 million events per year. So it also helps us to save cost and also helps to boost our performance. So having observed different problems and issues, we had a lot of ideas to improve how we did CQRS event sourcing. However, reality hits us. So since we are a math-based company and we pride in saying that we provide all kind of possible mathematical interaction on a web interface. So way back in 2014 when we started, Flash and ActionScript was the only technology which can help you to create rich interactive experience on a web platform. But that time, all the major browsers announced that Flash is going to be killed soon and it will be end of life. So we have to slightly deviate from our plan to at least rewrite our entire core logic of our application of 600,000 lines of code into a completely different technology. This gave us a nice chance to really do a separation of concerns in the context that our old code of ActionScript handled everything. That means it handled presentation layer, it handled math validation, it also handled content generation. So when we rewrote our application, we at least picked modern web technologies like React and TypeScript, so that presentation layer was separate from that code. Then we had a mathematical validation layer which was responsible for verifying the answer a student provided is correct or not. Since we wanted to ship it on multiple platforms, so we made a choice. Kotlin make a good candidate because we can compile to JavaScript, you can compile to Android app, iOS app as a library, you can deploy the server. So those kind of partitions help. And it kept us busy for 3 years, and we were not able to make much progress onto our journey on event sourcing CQRS, but having that architecture helped us to change our technology stack in a very graceful way. And after we were able to roll it out, Corona hit us. And that's where my colleague, York, will take over.
Yes, so as you remember, in March 22, Corona hit us, hit Europe, and lockdowns of schools happened. And this was the situation where our management decided that we will open the platform and give it away for free. So our CFO approached one of our site reliability engineers and asked, hey, what about a factor of 2? Will we be able to handle it? Yeah. Factor of 3? So it turns out it was a factor of 4, and depending on, because the intensity was much higher, it was even more pressure that hit us. So after we had done that, the system was super slow, and we even had to lock out users. So basically, because of storage, so those innocent user submissions that we collect, and which is super precious data, because all the misconceptions of children are embedded in these, we're piling up in this one Mongo database, and yeah, that wasn't nice. And our user class store, don't even want to talk about it. So this was really a tough situation. And again, weeks of super nice teamwork, great team building event, and we managed to solve most of the problems. So first of all, we transferred the user submission store to Amazon, which is now in DynamoDB. And we created separate instances for the user class store, so that is a nice learning. So separations of concerns make sense. This sounds totally obvious, I know, but this is where we are coming from. And believe it or not, we came to the idea that we could change our 6-year-old servers and use SSDs, and they do make things faster, but lockdown. So there were no chips available, so just ordering servers for the data center took several months. So this was not a speedy, resilient, responsive whatsoever reaction. But we were able to survive the situation, and it helped actually Bettermarks as a business, because we came in contact with federal states, and these beforehand we sold to individual schools. Now we were able to sell to entire states, and that of course is a great leverage. So that's where we then went into so-called Landeslizenzen episode.
Right. So basically, following the Corona situation, the federal states of Germany started noticing us, and we were getting more and more, we're selling more and more licenses for entire federal states. And that meant that we had, from the engineering perspective, to adapt to growth. And all of those implementation decisions that I told you before and so on were coming to be a problem. We needed to scale. And we identified that our main problem is MongoDB. Specifically because in the current setup that we had it, being self-hosted, it was very complicated to scale it. And even scaling it would be a completely manual thing to do, which also requires to order servers, and you know how slow they are, and so on and so forth. So we decided that we need to migrate to database as a service, a solution, cloud solution. Yeah. So I'll tell you a bit about our migration strategy, but before that, I just want to mention that we were already working with AWS, and we were evaluating different solutions. We thought about using S3, we thought about using DynamoDB. We ended up choosing DynamoDB because of the cost. So for our use case, it was clear that this would be scalable, elastic, and the cheapest. And the way we planned out this migration was that first we would use DynamoDB just as a shadow. So we would just write every event to both databases and also migrate all the old events to the new. So at that point, we just have a duplication of the events, but we still read from Mongo, right? Then later, we would start also reading from Mongo. We couldn't stop writing to Mongo because you remember that I told you about our BI architecture. It is still localized in the local data center. So then we had to migrate the BI infrastructure to the cloud also. And after doing that, we would be able to stop writing to Mongo. By the way, we didn't reach all the way to the end, but you'll see that in a moment. Let's speak about the first step of just starting to shadow, to write events also to DynamoDB without reading yet. Yeah, so you can see that now on the right-hand side we have AWS. We were already writing to DynamoDB the user submission. This is one of the maneuvers that we had to do during Corona. And during the lockdowns, and we created an EventStore. There was, of course, a higher latency because now it's not in the same data center, but a latency of 20 milliseconds is bearable. So, yeah, it was very nice to use the backend was built with interfaces. It's actually built in Python with Pyramid and Zope interfaces, and it means that the code never speaks directly to Mongo. The code has a concept of event store and has a concept of a snapshot store, right? And there is an implementation of it for Mongo. So we basically just had to switch the implementation to DynamoDB. That was quite easy, and we really benefited from that architecture. At that point, Conrad supported us as a consultant, and that was great. So thanks a lot, Conrad. We did realize that we did have, unfortunately, tight coupling to MongoDB through our operational scripts. Because, as you know, MongoDB is very flexible in the queries and scripts that you can write for it, actually much more than DynamoDB. So it was easier for all kinds of maintenance tasks to create scripts directly to Mongo. Of course, now they are no longer valid because they're not using those interfaces. Yeah, when we migrated, we had to use batch write for DynamoDB. Because, as I said, there's a latency. So if you want to now migrate millions of events, that latency would, of course, be meaningful. Batch write is much better. The downside is that we made a mistake. You need to handle unprocessed items. If you're writing and some are unprocessed, you get a response that tells you, and you need to loop over until you finish all unprocessed items. It's written in the documentation. We didn't read it. Yeah. For the retry strategy, so by default, it was using an adaptive retry strategy, which means that it's exponential, the weight is exponential. This was actually bad for us because on times where the connectivity was down, it meant that the request was hanging, right? So we had to switch to standard retry strategy. And yeah, we didn't say it until now, but data privacy is super important in the school sector, and we are not allowed to put any private data on, even on servers that are located in Germany but are owned by a company that is American, like Amazon. So we had to make sure that there is no private data whatsoever. The one place where we still had private data were those special events that we created for the change of school year, because at that point the users and the classes are no longer available. So we had to store their usernames, which are identifiable. So the solution was to encrypt. We had to encrypt the payload of some of the events so that we don't store private data. And now Saurabh will speak about the next step of starting to read from Dynamo.
Okay, so we used DynamoDB with the great promise that scales infinitely software as a service and a lot of other benefits. So we thought turning on read will be super easy, but unfortunately, it was not so easy. So first part that I need to give a bit context. So Bettermarks had multiple partners spread across multiple states and countries. So we call them systems. So we had 30 systems. We had learned in our incidents that always segmentize. So we end up creating 30 DynamoDB tables for each system so that they're fully isolated and we can manage them individually. But what happened that when we turned on the reading for all the DynamoDB tables in our implementation code, we were using a single ton of DynamoDB connection. And every time we will turn on read, our system will just slow down with piling up slow queries and it will harm users. And you are not able to figure out what's going on. We did some code reviews with some external friends and among our team, and we realized that because you're using single ton of one DynamoDB, but you have to talk to 30 different tables, every time you switch the context, you need to kill the old connection and create a new one. That means we need to change our strategy. So we have to create a singleton connection for each DynamoDB table so that in case a request comes for a same system, then at least you don't need to kill the connection. So that gave us a huge performance boost, and we were able to stay stable. But the second problem hits us after that we observed that it will stay stable at the reasonable performance for a short while, but as days passes, maybe in 2 days, sometimes in 1 day, depending on the traffic, the slowness will pile up. And then we had another OS level bottleneck that we observed, that when you stop writing to DynamoDB, under the OS layer, there were a lot of connections to DynamoDB in a state close wait. And as time passes, they were piling up. So we learned hard way that Boto3 library somehow don't honor the TCP keep alive setting of your OS unless you add some certain special configuration. So we have to add those so that all those connections were killed in time so that they don't pile up on our given hardware, and that way we are able to not accumulate those connections, and then our performance stays constant and it was performant. After we were able to read successfully, we started to see what are the problems and bottlenecks into our actual implementation of event sourcing. So first one was that our logic was that every time a user requests a new snapshot, we look at the timestamp of the last event with which it was updated, and then ask all events from that point onwards. So in that MongoDB, it never hurt us, but in the case of DynamoDB, if there were no events, for example, last event was on Friday, but you're asking again on Tuesday, every time you will make an empty network request to find an answer, there are no events. So we learned that was a bad design because you made an empty request all the way to DynamoDB to get no answer. So we changed that. Instead of storing the timestamp of last event with which it was updated, we started to add a timestamp when it was last queried. So that really showed a huge performance benefit because we have less number of outgoing requests to DynamoDB, and it was super fast. Second thing that DynamoDB tells very strongly, which we overlooked because we were not sure about our events behavior, was that if you provide the data to DynamoDB with the same primary key, then it will silently overwrite it. Primary key in DynamoDB is composed of partition key and sort key, and they recommend, and it's a good advice, that use partition key wisely, which represents the distribution of your traffic. So we use partition key as a user ID so that if we have more traffic, we can distribute them across all DynamoDB partitions under the hood. And we use timestamp as a sort key. But since we also have some secondary events, the sort key was a timestamp in milliseconds, but despite having in milliseconds, there were some events which were at the exact millisecond. So we end up writing our events over each other, and we found a discrepancy between Mongo and Dynamo. So then we had an aha moment that we already have a unique event ID. So we said, let's make our sort key timestamp as a fraction. So we have a timestamp in microsecond when fraction is the event ID. So that guaranteed that our primary key became unique, and then we were able to ensure that we don't overwrite the data, and we are able to continue. Another aspect that we learned that we have a change-of-schoolyear operation. That means we need to filter through a lot of events, and then based on that, some business logic requirements, we need to delete some and we need to keep some. So at least in a current state, because it involves scanning of the entire DynamoDB table, it was super expensive and super difficult and time-consuming to do that. So right now, the only approach we have is to export all data back into S3, do filtering in the S3 bucket, and once you are sure, rewrite data back into DynamoDB. So we're still figuring out what's the best way, but that's what we are doing right now. Second, another problem was that currently our developers, teams, and we are used to sometimes debug or do a mass analysis by just querying MongoDB and figuring out what's going on. But in DynamoDB, it's super impossible. If you're not using your primary key, which is a combination of user ID and timestamp, it's cost you to scan, and if you have hundreds of gigabytes of data, it's super expensive. So that's kind of another problem. And since we were a bit afraid about scaling, so right now we are using DynamoDB scaling on demand. That means that it's allowed to scale as much as you want. So there's an option to optimize the cost so that we can provision capacity in advance, and we know that this is the capacity I'm going to use, so I don't need to pay for auto-scaling, which is, I think, factor of 3 or 4 expensive. But the problem that we have is, since we now do a segmentation, we have 30 partners, and every partner have a different user behavior. So now when we're writing infrastructure as code, we have to really hard code somewhere the user behavior of every partner so that we know that this is the capacity we need to provision. This is another complexity that we have not managed to solve it yet. Another problem that we learned, which was different for us in MongoDB, was that if you want to restore a backup in DynamoDB, you cannot do it in the same table. That means that you have to either do a downtime, that means turn off your system, delete the old table, and then restore in the same name, or you create a new table with a different name, and then in our case, it was not configurable, so you need to make a new deployment. This is something that we also learned, and it was very hard for us. And when we moved our EventStore to DynamoDB, there were multiple places where we did not care about performance in the code. So when we read from MongoDB in a same data center, it was a few milliseconds, but we observed that there were tons of places when calculating a projection or aggregate for a class, we were doing a huge loops over and over again. So that forced us to relook the design of all projections, aggregates, and then we need to really rethink how we can minimize the for loops, because then you can reduce the number of network round trip between our UMC, old-fashioned data center, and AWS. There are other problems that we created ourselves by shooting ourselves in the foot. That means that sometimes our client-side code was making tons of requests in parallel to our EventStore, which lead to DDoSing ourselves. So the only way was to relook your architecture, really think about how you want to handle projections, and then we were able to solve it. So in general, the great things were that we do agree that DynamoDB is a great solution for auto-scalability as long as you take care of your partition key and sort key correctly. There are other features that we talked about, Cozy, etc., could work great really with the feature of automatic expiring of data. So right now we're doing it manually, but in theory we plan to use expire feature to just expire data that you don't need. The important part was that since it's pay-per-use and we're a school product, so we have a predictable traffic on weekdays from Monday to Friday, then we have vacations of approximately 3 months in a year. So it was really helpful for us to save cost, and we only pay for what we use. That was really helpful. And then in terms of disaster recovery, in MongoDB, we were taking backup once a day, only for last 7 days, but we use point-in-time recovery from DynamoDB, so we have 35 days of backup, and you can recover at any point of time. And the most awesome part that we were able to use, because we wanted to re-architect our data warehouse using cloud technology, so it provides easy way to attach event handlers using DynamoDB streams and SQS so that we are able to forward events to any next downstream service. So in that context, my colleague York will talk about how we migrated our data warehouse using DynamoDB to AWS.
Yes, I'm already.
Yeah.
So it's just moving one box from one side to the other. It took us over a year to do that. Was a hefty transformation, but we optimized a lot of stuff. But as Saurabh already mentioned, this was super easy then to attach it to the EventStore using lambdas and ETL it and then push it into RDS. So that was the fun part. The not so funny part was migrating the data warehouse from A to B. We found lots of wrong information, so we had to fix that, and that's why it took so long. Another thing is that we had a hidden feature that was attached to our BI system. Don't do that, so do not mix up production systems and other systems. So this is the so-called cross-tab report. So every Monday, teachers get a list of activities of the students of the last week. This is super helpful for them. And it was a side project, and that's why we put it into the BI system. It was just an experiment. And it was successful, but we never productionalized this. So now we had to do it because we are not allowed to store private data at Amazon. But now we made use of the power of projections. So grabbing this entire data and, did I mention? So we have per week roughly 5 million exercises are being performed on our platform. So per year we have 700 million events. And that nicely worked together in writing this, and we used some client-side Excel generation. So this was now getting reaping the fruits of our work here. So that was a really nice one.
Right, so as I hinted before, we didn't finish the whole process. What?
We're so close.
So close. Yes. So the last part of moving the data warehouse is just happening now, and we will be ready now to stop writing to Mongo finally, which didn't happen yet. But now we are looking at some more growth, which is great, but we need to think again about how to optimize and how to be able to scale up. And the next thing that we're looking into is how to optimize the other side of event sourcing, which is the projections service. We are looking at different frameworks. It's currently quite open how we will do it. We were looking at Confluent Cloud and at Axon and EventStore, maybe build something ourselves. Yeah, and we also want, as part of breaking down our monolith, we already broke the monolith quite a bit, but we want to also extract the event dispatching into a separate service, and the projection aggregation into a separate service. And potentially we would like to at least allow certain projections to be asynchronous, so basically to start aggregating as soon as the events come in and not on demand when they are requested. So for the wrap up, this is you, right? Yeah.
So as a wrap up, as Bettermarks' motto that we say for students is learn from mistakes. So as we shared our journey, we also had tons of learnings that we learned from our mistake. So at least one thing that we learned, that event sourcing definitely makes sense into context of our domain, because it helps to create different use cases on demand from teachers and help us to scale our product very easily. However, how you do event sourcing could potentially add operational complexity to your entire platform. So that's what we learned while going through the entire journey. However, if you do it right, it also gives you freedom to perform architectural changes, technological changes very easily, so that you can really move fast. When we picked DynamoDB, we had a vision of pay-per-use, auto-scalable, and event-driven DB. So definitely it worked great as EventStore. However, it has some downsides for specific use cases. So either you adapt your use cases or look for more options which can support that. And in that context, this is why, as my friend Yar mentioned, we are looking at options which we could use to probably replace or use DynamoDB better to meet our future requirements. So in terms of outlook, I will hand over to York.
Yes. So two major directions we want to proceed now. First of all, after we started in 2008, so after quite a long time, we will add the next subject to our mix. So it's not better maths, it's Bettermarks. So we want to cover other topics, and we chose German, which is a total different animal. So we have now a bunch of mathematicians, but now we have to learn about didactics on how to learn German. And so we have NLP experts now, we have German teachers who support us, and we did some explorations, and this is why event sourcing makes sense for us. So whenever a feedback is fired, this is didactically relevant information, and we can make recommendation engines based on these feedbacks and the stream of what's happening to a student. And the second direction we're working on, currently we're an adaptive workbook, so it's about practicing. But we want to be an adaptive school book, because then we can attack the publishers who are school books, and you only get money, you don't get money for digital learning material, you have to get to the school book. So we want to come up with a school book, and again here we can see that we want to have adaptivity for teachers. So seeing live that students in the class are having certain problems, then being able to offer, let's say, a whiteboard content that exactly fits to the problems that the students are having currently is what we're dreaming of. And we think that event sourcing CQRS is the right way to proceed here. And there's lots of work to be done. So if you're interested in helping to improve learning outcomes from children, then jobs@bettermarks.com, we would be happy. Thank you very much.